Hello everybody. I can prepare for my quadrilateral properties tests by memorizing my properties and practicing. If you don't know your properties, this is not going to be a good test. That's just the reality. So you can know your properties or not. Here are your 5 ways to prove a parallelogram. 4 of them deal with opposites. 2 pairs of opposite sides congruent. 2 pairs of opposite sides parallel. 2 pair of opposite angles congruent, 1 pair of opposite sides congruent and parallel. All the shapes have at least one diagonals property. Parallelogram diagonals bisect each other. Rectangle congruent diagonals. Rhombus has 2. Diagonals perpendicular and diagonals bisect the angles. Rectangle also has a right angle or consecutive sides perpendicular, and the rhombus has consecutive sides congruent. Understand the difference between a property and a proof. A rectangle has these 2 plus these 5, 7 properties. A rhombus has these 3 plus these 5, 8 properties. The square has all 10. Understand the difference, though, again, between a property and a proof. 2 pairs of opposite sides parallel is a property of the rectangle. It does not prove a rectangle. Whereas a right angle is a property of the rectangle, and a right angle proves a rectangle, assuming it's a parallelogram first. It's a parallelogram with a right angle for it to be a rectangle. Uh, Diagonals bisect each other. That's a property of the rhombus. It does not prove the rhombus. Diagonals bisect the angles is a property of the rhombus, and it proves the rhombus. And to prove a square, the square is the baby of Papa rectangle and Mama rhombus. So to prove the square, it needs to have one of the Papa rectangle properties, or one of the Papa rectangle proofs, and one of the Mama rhombus proofs. So we start by identifying the shape. Which quadrilateral has diagonals that bisect its angles? Well, diagonals that bisect the angles, that's a rhombus. And also each other, that's all parallelograms. It could be a rhombus or it could be a square. The square has all of them. Which has perpendicular diagonals, that's a rhombus as well. It does have the square as well. Then we talk about how to prove a parallelogram must be a rhombus when it has one of the 3 rhombus proofs. Which of those 3 rhombus proofs is there? Diagonals perpendicular. If you know your rhombus proofs, then this is easy. If you don't, then you have a 1 out of 4 shot at getting it. A parallelogram must be a rectangle when? Well, I need one of the rectangle properties, either a right angle or diagonals congruent. There it is. This is very easy if you know your properties. If you don't, then you really have no way of getting it right other than a lucky guess. This is the same thing, but now we're applying actual shapes and letters to it. It wants me to prove a rectangle, so it needs to have one of the rectangle properties. So one of the choices needs to either be a right angle, or leading to a right angle, or congruent diagonals. BT, HE. BT is a diagonal, HE is a diagonal. They're congruent. Yes, that is diagonals congruent. 6 wants me to prove that EATK is a rhombus. EATK, make sure the letters go in order. So I need one of the 3 rhombus proofs. Choice 2, EA is congruent to AT. That's consecutive sides congruent. That's one of your rhombus proofs. Moving along. This, I think, is the most straightforward, simplest question in this unit, as long as you're prepared for it. It does incorporate a couple of properties, but if you're prepared for it, you really don't need to know much. For the perimeter of a rhombus, if PR is 16, well, since the diagonals bisect each other, that gets cut in half to 8 and 8, and QS gets cut in half to 15 and 15. Since the diagonals are perpendicular to each other, I have right angles, and I have 2 sides of a right triangle. I want to find the third. I do Pythagorean theorem. The legs are 8 and 15, so it's 8 squared plus 15 squared equals c squared. 64 plus 225 equals c squared. We finish up our Pythagorean theorem. Use the calculator for radical 289. Radical 289 is 17. So I just found a side of the rhombus. It wants the perimeter. Well, another property of the rhombus is that consecutive sides or all sides are the same. 17 times 4 is 68. So that's probably the most straightforward question on your exam. You don't have to have lists of things memorized. It's just being prepared for it. You cut the diagonals in half. You do Pythagorean theorem to find the side of the rhombus. And then since there's 4 sides and they're all the same, you multiply by 4. We're back to our complex triangle problems, incorporating parallelograms now. There's 3 properties of the parallelogram that you may need for angles. Most common, opposite angles are congruent. You also have consecutive angles are supplementary. Meaning they add to 180. And then you also have alternate interior angles, which come from the parallel, which can come up as well. It's telling me, so let's see, it's telling me that angle R is 124. Since opposite angles are congruent, angle D is 124. I can do consecutive angle supplementary to fill in angle E, but that's not going to help me. From here, we look for linear pairs and angles of a triangle, going back to September. I see a linear pair. 180 minus 124 is 56. It's telling me that AF is congruent to DF. Well, whenever I see that 2 sides are congruent, mark the sides, mark the angles opposite them. So this is 56 as well. And now I have 2 angles of a triangle, so I can add them and subtract from 180. When we did this lesson, there was different levels of it. It got pretty hard. As far as your test goes, it's going to be around this level. You're going to have to use opposite angles of a parallelogram are congruent. You're going to have to expect to look for linear pairs, angles of a triangle, expect to use your isosceles triangle if 2 sides are congruent, the angles opposite them. I'm not going to give you one of your tests like some of the ones that were later on in that lesson, but it's something you could see on the regions. Which brings us to proofs. So I've got 3 proofs that's going to be on there, a 4-pointer and 2 6-pointers. We need to know our properties of our parallelograms in order to do this. So, statements, reasons. I'm always proving triangles are congruent. Is it obvious which triangles I'm proving congruent? It is to me. So what properties of the rectangle are going to help me with those triangles? To me, the most obvious property is 2 pairs of opposite sides congruent. So I'm going to say that ABCD is a rectangle given. And then DA is congruent to BC. A rectangle has 2 pairs of opposite sides congruent. What other property of the rectangle is going to help me? I've got congruent right angles. So we can do the 1 and 2 thing there to make it easier for you. Angle 1 is congruent to angle 2. A rectangle has congruent right angles. That's how we use the properties of the parallelograms to get corresponding parts of the triangles. I got nothing else with the rectangles. I've got another given. I have 2 pairs of things congruent. I need 3. M is the midpoint of AC given. A midpoint creates 2 congruent segments, so I do that mini proof. AM is congruent to MC. Now I have three pairs of things congruent. That's what I want. So now I can state the triangles are congruent. I'm run out of space here. So DAM and DCM. In fact, here, I'm just going to show you on the answer key how it ends, how it finishes off. Oh, this is not the right answer key. Oh, this is not the right answer key. Found it. So again, once I have my three pairs of things congruent, I can state the triangles are congruent. I marked two sides and one angle. The angle is in between the two sides. That's SAS. And then what they want us to prove, CPCTC. Now we get into the more complex proofs. We're always going to have to prove a parallelogram first. All right, that's what I've trained you to do. We need to prove the parallelogram first. So these are your 5 methods for your parallelogram proofs, and the most common, I'd say, are those two right there. 2 pairs of opposite sides congruent, or 1 pair of opposite sides that are both congruent and parallel. So instead of writing this whole thing out, I'm just going to go through the answer key because it's just a lot to write out and it's not super organized. So I always want to prove the parallelogram first. So it gave me EH is congruent to OP, and it gave me EP is congruent to OH. That is one of my 5 pictures. That is 2 pairs of opposite sides congruent. So once I have that, I state that it's a parallelogram. A parallelogram has, in this case, 2 pairs of opposite sides congruent. And yes, the parallelogram proof will be that simple. Now that I have that, I need to use the parallelogram to help me with my triangles. So the first thing that I've trained you to do is to look for your Z, to look for your alternate interior angles. There it is. There are your alternate interior angles. Angle 1 is congruent to angle 2. I know it's long, but a parallelogram has parallel lines cut by a transversal, which create congruent alternate interior angles. Once you have that, again, I've trained you what's coming. I'm sure that addition or subtraction property is going to be coming. It's telling me that, let's get a different color here. It's telling me that EJ is congruent to OG. Well, that is more than what I need. It's part of what I need, so I'm going to have to do subtraction. So I start my whole subtraction process, and that's there. So if you know how to do subtraction, then that shouldn't be a big deal. But if you don't, then you're not going to be able to do this. All right, I've got 2 things. I move on to my next given. I've got some perpendiculars. I know that perpendicular lines form right angles, congruent right angles, I should say. So that's where these come from. Once I have my 3 things, it ends the same way as the other one did. I state my triangles are congruent. I state what they want me to prove, CPCTC. You're going to have to prove, let me get a new color, you're going to have to prove the parallelogram. That was this and this. And it was given to you. Essentially, it was given. Both those things were given. Once I had that, I state the parallelogram. I use the parallelogram to get alternate interior angles. It's possible I may need the parallelogram for other properties as well, but almost definitely you're doing the alternate interior angles. From there, expect to do addition subtraction property. In this case, we had to do subtraction because they gave us this, which was too much. So I had to subtract. I followed that process. I did a mini proof of my perpendicular. That was my 3 things. Once I had that, I state the triangles are congruent. What they want me to prove, CPCTC. And then there's one more big proof, and that is 15 and 16. Again, I know I'm always proving a parallelogram first when I see this picture, but before that, when they want me to prove multiplication, I work backwards. AB times TE equals AE times TR multiply CPE. cross products are equal. Before the multiplication is always, always, always your proportion. The reason for your proportion, see assist tip. Whatever's being multiplied must be diagonal from each other. So A, B, and TE should be diagonal because things are cross-multiplied diagonally. AE and TR. Before the proportion is always the triangle similar. The reason for the triangle similar is always angle, angle. What are my triangles? It is pretty obvious to me in this particular example, but you could also look at the letters horizontally and vertically. ABAE, yes, ABE is a triangle. TRTE, yes, TRE. It doesn't matter how I name the first one. I'll go ABE. But for the second one, the letters must correspond. A corresponds to T. B corresponds to R. E corresponds to E. So I know that's how my proof's going to end. No thinking. You don't need to know anything about proofs. You just need to practice that and be able to duplicate it. Now that I have that, I start back up at the top. So again, that is this right here. Now I start back at the top. I know I'm going to have to prove a parallelogram. So it's giving me that AF is parallel to CT and AF is congruent to CT. Well, that's one of my 5 parallelogram pictures. So once I have that, I can state that it's a parallelogram. A parallelogram has one pair of opposite sides congruent and parallel. If you don't know your ways to prove a parallelogram, you can't do this. Once I have the parallelogram, I look for my alternate interior angles. I look for my Z. So there's one transversal. There's my Z. There are my alternate interior angles. And then I have another transversal. So I carve this one out. There's my Z, and that gives me those. So I got 2 pairs of alternate interiors. So there's my angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. A parallelogram has parallel lines cut by a transversal, which create congruent alternate interior angles. I need angle, angle. I've got angle, angle. For similar, I just need 2 pairs of angles. I got my 2 pairs of angles. I'm done. You could have also done vertical angles, but I don't need it because I already have 2 pairs of things, but you have that as an option as well. These are not hard, these are not easy, excuse me, but they're really not that bad either if you know how to do all the little pieces. We spent a lot of time on these proofs. I'm not giving up on these like some other people. I know that many of you have the opportunity to do it. You just gotta put the time in and do it. Know your properties or don't. If you don't know your properties, this test is going to be a complete disaster because almost every question requires you to know your properties except maybe number 7 and 8 and maybe 9 and 10 you can kind of get away with without 100% knowing all your properties. Know your properties. Here they are again. And if you don't, then it's just more questions you're not going to be able to get correct. That's all I got. Put the time in or don't. The choice is yours. Goodbye.